Alrighty, you guys. Today is going to be a little bit of a review of everything we've learned up to this point. Okay, so let's go ahead and just dive right in. Our first 4 questions, it is asking us to convert each degree measure into radians and each radian measure into degrees. Okay, so first of all, if we look at number 1, is this a degree or a radian? We know this is a radian because it has a pi in it, okay? So what we want to do to convert radians to degrees, so I'm going to just write it over here again to give myself some space. 29 pi over 18, I want to multiply it by 180 over pi. Okay, because what happens when I multiply it by 180 over pi? My pi's cancel each other out. I can go ahead and reduce anything at this point if I see things. I know that 18 I can divide by 18, which would just give me 1. 180 I can divide by 18, and that will give me 10. So now all I need to do is do 29 times 10, because everything else either reduced or canceled out, and that's going to give me 290 degrees. And there's my answer. Okay, number 2, this guy, we can easily see that he is in degrees. Okay, so that means I'm going to take 90, and we can even write 90 over 1, because that's the same thing as 90, and we're going to multiply it by pi over 180. Okay, different than 180 over pi. So again, multiplying fractions, now it just becomes, can we reduce things? Okay, well, I know I can divide both 90 and 180 by 90. Okay, that'll give me 1. That'll give me 2. So now that everything else has reduced or canceled, okay, all I'm left with is pi on top over 2. So 90 degrees is also pi over 2 in radians. Okay, so let's do that again for number 3. I have 75, which is in degrees, so I'm going to multiply it by pi over 180, and again we can write this as 75 over 1, just so we can see that we're multiplying a fraction times a fraction. Okay, so now I can go ahead and reduce. If you want a calculator here, I know I can't divide 180 by 75, but I can divide 75 and 180 both by 5. Okay, so 75 divided by 5 is going to give me 15 when I divide those both by 5. 180 divided by 5 is going to give me 36. Okay, and let's see if I can divide by anything else. I believe I can divide both 15 and 36 by 3. So 15 divided by 3 is going to give me 5. 36 divided by 3 is 12. Okay, now everything is reduced, so all that's left was 5 pi on top and 1 times 12, which is just 12. So 5 pi over 12. Okay, beautiful. Number 4, this guy is a radian, so I'm going to go ahead and take this guy, pi over 3, and multiply it by 180 over pi. Okay, we want to do that because we want the pi's to cancel each other out. One's on top, one's on bottom. Okay, now we can just say, okay, well, I have a 180 left on top, I have a 3 left on bottom, but what is 180 divided by 3? Okay, that's really what that fraction is saying. 180 divided by 3 is 60 degrees. Beautiful. Okay, for our next 4, we are asked to find the value of the trig function indicated, and we have sine, tangent, cosine, and sine. So we have all 3 of our trig functions. So let's go ahead, on top of my paper, I'm going to go ahead and remind myself my trig ratios. Sine is opposite over hypotenuse, or so. cosine adjacent over hypotenuse, ca. And tangent is opposite over adjacent, toa. So, ca, toa. Okay, we're going to use these guys to find our trig ratios here, or the value of the trig function. Okay, so let's go ahead. I'm going to zoom in just a little bit on number 5. Okay, so it is asking for sine of theta. Theta is right here, so this is where we're standing at that angle. Okay, because it's asking for sine, I know I'm going to have to use so. Okay, so now that I know where I'm standing at theta, I want to label all 3 of my sides. Okay, so opposite from where I'm standing would be 20. 15 would be my adjacent side, and then 25 across from that right angle is my hypotenuse. Okay, that's going to help me out now. So now all we have to do is say sine of theta equals opposite over hypotenuse. Okay, opposite is going to be 20 over my hypotenuse, 25. Okay, now if you put this fraction into your computer, it would mark you wrong because it is not reduced. Okay, well, we can reduce this fraction. I can divide both of those numbers by 5. That would give me a 4. That would give me a 5. So sine of theta really is 4/5. And that's my reduced value. Sorry, the camera's a little shaky. Okay, let's go ahead and look at number 6. So now it wants tangent of theta. So tangent, I know I'm going to have to use toa. Okay, theta, I'm standing right here at this angle. Based on where I'm standing, let's go ahead and label our 3 sides. Okay, so the side that's opposite from where I'm standing would be 5. The side that's adjacent or next to would be 12, and my hypotenuse always across from that right angle, 13. Okay, so now we can just say tangent of theta equals opposite over adjacent, 5 over 12. Can I reduce 5 twelfths? No, I cannot. It is reduced, so that is our final answer. Beautiful. Alrighty, cosine of theta. So because it wants cosine, I know I'm going to have to use ca. Okay, theta means I'm standing right there. Based on where I'm standing, let's go ahead and label our sides. The side that is opposite from where I'm standing would be 12. The side that is adjacent or next to would be 16. Hypotenuse is always across from that right angle, so 20. And now we can say that cosine of theta equals adjacent over hypotenuse, 16 over 20. Okay, can I reduce this fraction? Yes, I can. We want the biggest number that we could divide both of these numbers by, also called the greatest common factor. I can divide both of them by 4. Okay, so if I divide 16 by 4, that's 4. If I divide 20 by 4, that would be 5. So cosine of theta in this case, final answer is 4/5. Beautiful. Okay, last one where we're looking at a right triangle. So it wants sine of theta. So again, sine, I know I'm going to have to use so. Theta, I'm standing right there. So now let's go ahead and label our sides based on where I'm standing. Okay, the side opposite would be this really ugly side, 3√19. It's okay that it's ugly like that though. Okay, the side next to where I'm standing would be 5. Hypotenuse, always across from my right angle, 14. So now we can say sine of theta equals opposite over hypotenuse. And yes, you want the whole thing on top. 3 root 19 over 14. Okay, now the only way we could reduce this fraction is if 3 and 14 could both be divided by a number, right? The root 19 we can't reduce. But if we could divide 3 and 14 by the same number, then we could reduce it. But in this case, we can't. So that is our final answer, 3 root 19 over 14. Awesome. So that's finding the trig function when given a right triangle. Okay, you're using SO, COD, TOA for those. Now, for numbers 9 through 12, we are asked to find the exact value of the trig function. So same thing, sine, cosine, and tangent. But this time we are asked to find it using a degree. Okay, so what we need to do here is we need to look at our unit circle. All right. Okay, so here's our unit circle. I'll zoom out for you. In fact, I might just zoom out so maybe we can see it both at the same time. Okay, so for number 9, sorry, it's really small now. It wants the sine of theta, but theta is this degree right here. Negative 570 degrees. Okay, well, first thing I need to do is I want to make it, just kidding, I'm gonna zoom in because that's so small, you can barely see it. Okay, so first thing I wanna do is I wanna make it so it's within one circle. 570 is more than 360. One circle is 360 degrees. So what I'm gonna do is I'm going to take my calculator and I'm just going to take 570, doesn't matter that it's a negative right here, minus 360. Okay, so what this really means is negative 570 is also the same as negative 210 degrees. Okay, so here's what we need to do. On our unit circle, here's where it might throw us off a little bit. Because it's negative, usually our unit circle goes this way. We see 0, 30, 45, 90, blah, blah, blah. It's getting bigger. We're going that way. This time, we're going this way. Okay, so I believe the right, in positives, it's counterclockwise. Negatives, it's clockwise. Okay, so negative 210, if I were starting right here, okay, well, that would be 0, and I'm going this way. Negative 180, if I went that way. But then another 30 degrees would be right here. So 150 degrees is actually the same as negative 210 because 180 plus another 30 degrees going that way would give me my negative 210. Okay, so one thing I want to make on our notes though. So remember, a couple things we need to remember here. We are given coordinate points on this unit circle. Okay, we see all around this unit circle, we are given coordinate points here. Okay, coordinate points are usually written x comma y, but with trig, the cosine is our first value, the sine is our second value, but then it's gonna ask us for tangent. The tangent, you need to take the sine, divide it by the cosine. Okay, so that one we're gonna have to, is gonna require us to solve a little bit. For now, we can just look. Okay, so if I look back at number 9, it asked for the sine of negative 210. Okay, well, we found that on our circle. It's right here, excuse me. Okay, so I just look at my coordinate point that goes with that place on the circle. The first one is cosine. And this guy is my sine. So positive 1/2 would be the sine of negative 210 or negative 570. 1/2. And we're done. Okay, it takes a little bit of almost like solving a puzzle, looking at the unit circle. We had to go negative, so we couldn't go this way to just find the number. We had to go backwards in order to find that negative number. Okay, so let's try it again. So I have cosine of theta, and the degree is negative 930 degrees. Okay, I want this within one circle. So we're gonna take our 930 and we're gonna just subtract 360 until it's within one circle or under 360 degrees. Look at that, you guys. It's the same as number 9. Okay, so negative 930 degrees will be on the same spot on our circle as negative 210 degrees. Oh, this is awesome. Guess what? We already found negative 210 because we had to go that way for negatives. Okay, this time it wants the cosine of negative 210. So that would be our first value in that coordinate point. So negative root 3 over 2. Negative root 3 over 2. Sweet. So we found that on our circle. The cosine is the first value in the coordinate point. Boom, right there. Okay, now for a little challenge. Numbers 11 and 12 want tangent. Remember, tangent, we can't just look on the coordinate point. We actually have to divide the second coordinate point by the first coordinate point. But we can do that. We know how to divide. Okay, so this one, it wants tangent of theta, and the degree is negative 510 degrees. Okay, so first of all, I want it to be within one circle. So let's take 510 minus 360. That's going to give me negative 150 degrees. Okay, so now on my unit circle, I'm looking for negative 150. Again, I'm going this way. So starting at 0, I can't go all the way to 180. That would be too far. So it would have to be 30 degrees from that 180. Okay, which would be right at this line right there. Okay, so negative 150 is also the same as positive 210. Okay, so now let's go ahead and look at our coordinate points right here. This guy is our cosine. This guy is our sine. But now what it wants us to do is find the tangent. Okay, this is gonna look, I'm just warning you right now, this is gonna look really ugly at first. So we need to take our sine, negative 1/2. Okay, so write this down with me. Negative 1/2 divided by our cosine, negative root 3 over 2. Negative root 3 over 2. Okay, now, here's how we're going to rewrite it to make it prettier. We know that dividing fractions, a fraction divided by a fraction, really means we're multiplying by its reciprocal. So we can take the first fraction, doesn't change, but then we're actually multiplying by the reciprocal of the second fraction. So you multiply, flip those guys over. So negative 2 over root 3. Okay, so here's what I notice here now. My negatives cancel because negative times a negative is going to be a positive. My 2's cancel because the same thing on top and bottom is just 1. So all I have now for my final answer is a positive 1 on top and a root 3 on bottom. Beautiful. Okay, we're just going to leave it right there. If it didn't want a radical on bottom, which sometimes your answer doesn't want, what we would do is we would rationalize it. We'd multiply the top and bottom by root 3, which would leave us with root 3 on top over just a regular 3 on bottom. Okay, that's also another answer, but we can go ahead and just leave it right there for now. Okay, let's try it again, you guys. So this guy wants tangent of theta. The degree is positive 300. So good news, we don't have to go backwards on our unit circle. We can just go directly and find 300 degrees. Okay, so 0, here's my degrees, boom, here's 300. Let's look at our coordinate point. Again, this first one is my cosine. This second one is my sine. In order to find tangent, we need to divide sine by cosine. Okay, so my sine, again, it's gonna look really ugly at first, negative root 3 over 2. Negative root 3 over 2. And it's divided by the cosine, which is positive 1/2. Okay, well, when you are dividing fractions, what you're really doing is multiplying by the reciprocal. So keep the first fraction the same, negative root 3 over 2, multiplied by the reciprocal, flip it over, 2 over 1. Okay, look how nice this guy is. The 2's are the same on top and bottom, they cancel out. All we have left is a negative root 3 on top, and whenever the 1 is on bottom, we actually don't need it. So our final answer here is just negative root 3 is our tangent of that degree. And there we go.